What is a differential equation? Differential equation is an equation that may contain the independent variable, which could be x or t. It contains or may contain the dependent variable, usually y. And most importantly, it contains the derivative of y prime or dy dx, or dy dt, if t is your independent variable. So here are some examples of differential equations. Y prime is equal to 3x. That's an equation that contains both x, the independent variable, and also y prime. Here's another one just like that. Y prime is equal to x squared plus 1. And those are fairly simple to solve. We'll solve equation number 1 in a minute, and you can see that we can solve those pretty simply just using integration. If, however, our differential equation contains a y, for example, y prime is equal to 3y, that's a harder differential equation to solve, because that equation, remember, y is a function. Y is not just a variable. And so the solution to the differential equation is going to be a function y where its derivative is 3 times the original function. A little bit trickier to solve. Let's look at equation number 1. Y prime is equal to 3x. If I integrate this, if I know the derivative is 3x, then I know that the original function I started with using the reverse power rule is 3x squared over 2 plus c. I can add any constant at all, and this is called the general solution. And if I was given a little bit more information, such as the value of y when x is 0 is equal to 1, that's called an initial condition. And it's called an initial condition because I'm giving you the value of y when x is 0, although we do generally call any one particular point that you're given an initial condition. But we can plug that in now. Plug that into here, and we get, I'm sorry, this should say just y is equal to 3x squared plus 2. We plug in our initial condition, and we get 1 is equal to 0 plus c, or c is equal to 1. And now we have y is equal to 3x squared over 2 plus 1, and that is called our particular solution. Let's look now at equation number 3 that I gave you before. Y prime is equal to 3y. Now that's a little bit harder because there's a y in the equation. And we're going to use a method here called the method of separation of variables. What we want to do, separation of variables, is we want to separate all the x's and the y's. We want all the y's on one side of the equation and all the x's on the other side. And at first glance it might not look like there are any x's, but let's rewrite that y prime as dy dx. dy dx is equal to 3y. I'd like to put all the y's on the left and the x's on the right. So this becomes 1 over y dy is equal to 3 dx. Take a look at that and see what I did. I multiplied both sides by dx and I divided both sides by y. And now that I've separated the variables, I can take that equation and integrate both sides. When I integrate both sides, let's do the right-hand side first. The integral of 3 dx is 3x plus a constant. And on the left side, the integral of 1 over y dy is ln of y, also plus a constant, but I'm just going to, I only have to put the constant on one side. Now we're almost there, but I don't really want the answer to look like ln of y equals something. I want the answer to look like y equals. So I'm going to do e to the on both sides. So I have e to the ln of y is equal to e to the 3x plus c. And e to the ln of y is y. E to the 3x plus c is e to the 3x times e to the c. And that is my general solution. If I want to find a particular solution, I would have had to have been given an initial condition. So let's come back up here and let's say I gave you this initial condition, IC, initial condition, that y of 0 is equal to 2. Now plug that in, plug in the initial condition. 2 is equal to e to the 0 times e to the c, which means e to the c is equal to 2. And now I'm just about done. Just squeeze this down a little bit more, make some room. I know what my e to the c is, so coming up here I have y is equal to, e to the c is 2, let me put that first, times e to the 3x. And remember, the solution to a differential equation is a function. And think about this for a minute. Does this function satisfy the differential equation? Satisfy the DE, the differential equation? Well, let's check it right over here. Check. I need to see what y prime is. Y prime is, I have to use the chain rule, so it's 2e to the 3x times 3, which is 6e to the 3x. And that's the left-hand side, and the right-hand side is 3y. 3y means I take 3 times my function 2e to the 3x, which, aha, that's also 6e to the 3x. So this checks out. And that, in a nutshell, is how to solve an initial value problem using the method of separation of variables.